Here we have a question that is, we have to show P and Q implies to P or Q is a tautology. Now, what is a tautology? A tautology is a proposition that is always true. Now, it is a compound proposition. For example, we have here two examples of a tautology and a contradiction. We know that when we have or from true or false, it can be only be true or only be false, only be true. And for and, if there is a true and there it should be always be a false. So this proposition here is always true, and this proposition, compound proposition here, is always false. Now we have to prove that P and Q implies to P or Q is a tautology. That means it is a proposition that is always true. Now this is our second line. Now how we come from this line to this line? To understand this line, we have to understand this. Here we have a truth table where we can see that negation of P or Q and P implies to Q is equivalent. For example, we can take this as P and we can take this as Q, and this is negation of P or Q. And from the truth table we can see that they are both logically equivalent, so we can write this line instead of this line. In the next line we use the first De Morgan's law, which basically is we take the negation inside the bracket, the and turns into or, and the q turns into negation of q. In the next line we have the associative and communicative laws of disjunction. Now, for example, what we have done is that we have given up all these brackets, and then we rearranged P and negation of P inside one bracket and Q and negation of Q inside another bracket, and then we just rearranged everything. Now P and not P is true, which we knew from our previous example, and Q or negation of Q is also true, which we also knew from this truth table. Now let's get back to that. Now in the last line we have T or truth, which is should be truth, because for or, if either one of them is true, the end result will be true. And that we can prove now that P or and Q implies to P or Q is a tautology.